So let's broaden it out a little bit here, right? So there's actually, if you were at OFC last week, there were like tons of talks about machine learning at work. So maybe we should have a track like that here at OCP. So I'm going to generalize it. I see you, just hold on a second. I want to generalize this conversation now to be more about telemetry as a whole, right? What do we as a community want? What are some things that OCP should start doing as a community, or if people are passionate about building systems on top of telemetry, if we're really concerned about getting this inter-switch, inter-ASIC standardization, making sure we really have telemetry well defined as a standard. If you're more interested in higher layer tools, I'd love to hear kind of what folks are interested. First, operators in the room, if you run a network, raise your hand. Okay, awesome. We'll start with you all, kind of like, what would you like from this in-band telemetry and analytics work?
Hi, Kinji from China Mobile. You know, the things, what you present here is very useful, interesting, but the single biggest, the most challenging us is to associate all the data together from a holistic view. It's not like, you know, most difficult issue for us is something happening on one node, but the root cause is far away, not on this particular telemetry data. That is the thing we are looking for right now.
Great, thank you. Other folks that want to talk about, thank you from China Mobile, who has that problem from the operators? Or what are your in-band telemetry, or what problems are you trying to solve with in-band telemetry? Oh, yeah.
So for us to get in-band telemetry today, we have to put taps in a lot of critical areas in the network, and we have to peel that off to a packet aggregation network, and then we have to send that to some tools, which are usually high-dollar tools, to go do that analysis for us. And that's typically a data set that's on an island. So if there's an opportunity to pull that same packet metadata, even knowing most of the packets are going to be encrypted soon, I think that's hugely valuable if that can be standardized and brought to market.
There were a couple of other folks who were operators I saw raise their hand over kind of in this area. So if you want to chime in, it's often good fodder for the rest of the folks to chime in with what solutions we're building. So anyone else from the operator community want to talk about in-band telemetry? Otherwise, we've got a few folks who want to chime in on some of those points from China Mobile and from you. Go ahead.
Yeah, hi. I think yesterday's keynote, Andy mentioned about how the north-south traffic hasn't gone up by much, but the east-west traffic has gone through the roof. With this telemetry and metadata, and then it's going to aggravate that east-west traffic, right? So how do we achieve building intent-based deep learning without drastically increasing the east-west traffic? Has that been thought of? And how do you ensure that telemetry traffic is metered or controlled?
Yeah, so I can touch point, and if you guys want to chime in as well. You know, it's so on China Mobile, I think, great question, great point. So I think one of the advantage of in-band network telemetry is the fact that, you know, you can actually, as the packet goes through this journey, it may start from an application or from, you know, another part of the network. So that application may be misbehaving and generating too much traffic. And so some other place in the network is experiencing congestion right now. I'm just making an example. So the fact that now you have this history of the packet across the network allows you at that point where the anomaly is detected to reconstruct the full history, you know, where this specific traffic is coming from, what is the source of that packet, what was the path of that packet. Is it like maybe because I'm actually, you know, my network is not load balanced properly? So the fact that INT build that correlation into the packet itself, as metadata, allows you actually to find this kind. And we, doing our initial POCs and production trials with INT, we found this, unexpected findings from customers saying we're able to root cause problems that they never thought they had before, right? And the ability, for example, to do congestion analysis, see, in the queue what packets were part of that congestion, allows you to detect if an application is misbehaving. Detecting the path allows you to detect if there was an imbalance in your network. So that is INT, I think, helps a little bit there. On the, I think, packet broker use case, yes, we hear this customers saying, that's the way we monitor networks today, and these are great tools. I think, yes, one of the disadvantages here is that you have to create a parallel network that is your monitoring network. I think what INT provides on top of packet brokers, which are different use cases, I think, but it's like the visibility inside the switch. And with packet broker, you can see the packet on the wire. With INT, these switches and routers know everything about the packet because they forward the packet, they see the packet, they take decisions. So if you can actually take the relevant information out of it, then you can really go to the bottom of these problems. Yeah.
You want to weigh in?
Yeah, so I think that the first step is to do as much measurement as you can. And IOM and INT are a good first step because you get a lot of information, not only about a certain place in the network, but about the entire path of the packet. But that's just the first step. The second step is you get a lot of telemetry information. Now you need to filter that information. You need to decide which information to export. And that's the second challenge. And finally, the third challenge is how you process that information. And I believe that's the biggest challenge and probably needs the most work at this point because we're just at the beginning. And I understand why that's a big issue because once you have so much data, you need to somehow process it and make sense of it.
And one thing that I have not covered in this is for processing, you need end-to-end information. So for customers, they need all the way information up to the application. So we are talking about the lower layers, but eventually it has to be tied to the application as to what is causing the application to slow down and why is it behaving that way. So some of the big networking vendors are working towards it, but this is something that the open community needs to look at as well.
I just want to make an answer to Sugan's question, right? So on the east to west, I agree. That was one of the lessons learned from when I said, the initial trials we did with some customers, the ability to select what applications you want to instrument, the ability to select what metadata goes in, and tailor to the specific use case of the customer. Because, yes, these switches can do 6.5 terabit or more, and don't even say they don't care. But you don't want to generate too much extra bandwidth in your network. So the ability to have this mechanism in place, like watch lists and triggers, and they help mitigate that. And if it's a small price to pay, people like customers are going to go and pay that price. In exchange, they get visibility and they get a lot of troubleshooting, ability to troubleshoot problems, avoid problems. I think the closed loop use case is a great use case that we are seeing, that goes back. If you have real-time information from the network, you can react and you can do certain things. So, if you have the right trade-off, I think it's always, a trade-off. But if you can be very selective on the traffic analysis and telemetry, then it's a right price to pay. Yeah.
So please help me thank all the speakers again. We're at the end of time. Just a quick question then. Okay, so.
So is there any thoughts given to what data ought to be consumed on the SoC itself, and does it even deserve to be kicked out of the SoC all the way up to some network server to do some analytics. A lot of the problems are very local. So if you can actually prevent the SoC from getting into some sort of a failure case, you don't need to actually ship all of that data out.
Yeah. Absolutely.
Yeah, I think the point there was like, you've got compute at different layers, right? You can diagnose stuff locally, even possibly on the NIC, some on the system, and then some data you pop up. But the more you pop up to a central place, then the harder it is to then figure out, do correlation end to end, because now you're kind of bringing together different pieces. So that's generally the problem I know when we do analytics and remediation at Facebook. How do you kind of unify across and then tag information and then sync timestamps, sync everything else? How do you know that the packet over here was part of the same application or the same container as the packet over there? It's a challenge. So please help me thank the speakers. I'm sorry I have to cut it off here, but just from an official standpoint, thank you to our 3 speakers. Thank you all for participating in the workshop. This is the end of the workshops. We are certainly open. We're going to post something to the list, Open Compute Networking list. We would love feedback about how you like the format this year, if there's stuff that you would continue for us to do or stuff we could get better at for next year, and any other feedback, not even just for next year, but for continuing workshops. Thank you.